There are some issues that affect the characteristics of the cable. So we see that, for example, for the copper cables are affected by different level of what we call interference. And interference talks about the fact that the electromagnetic or the radio frequency signals that are surrounding the cable can actually affect the efficiency of the signal inside the cable. So this video here illustrates this notion. So if we have a signal which looks like this is a pure digital signal. We see that there is an interference due to electromagnetic or radio frequency signals, which looks like this, in which case the digital signal will be affected and will look like this. And then finally, what we will receive at the other end is the original signal distorted or deformed using the interference signal. Due to this issue, some of the bits might actually change its value on the receiver side due to these types of interference. So the interference can be classified into different types. We will talk about two different types here. So we have, as we said, the electromagnetic interference or the radio frequency interference, which is generated or which is affected by external signals from the different objects inside any place, like for example the light bulbs, the microwave at home, these different objects they use and they emit different electromagnetic or radio frequency signals which affect the signal inside any copper cable. We also have crosstalk noise, or the disturbance which is caused by some electric or magnetic fields of a signal in one wire. So within the actual copper cable, you have a signal which affects the signal inside another copper cable. So you have crosstalk, which means that you have a similar signal that affects your signal. So these are the two types of noises that can affect the signal inside the copper cable. So again, we have electromagnetic interference and we have crosstalk interference. And of course, depending on the type of cable, there are some techniques used to package the physical cable in order to mitigate these types of interference. So we have three types of copper cable. We have the unshielded twisted pair, and we have the shielded twisted pair, and we have the coaxial cable. The unshielded twisted pair looks like this, and the difference between the unshielded and the shielded is this green foil here, which is called the braided foil shield, and this is actually used to mitigate the electromagnetic interference coming from outside, coming from external sources, whereas the unshielded twisted pair does not use this extra shielding here. Of course, due to this, unshielded twisted pair is actually is prone to interference, is prone to external interference. However, this material here tends to be a little bit expensive, especially in long cables, and therefore UTP tends to be cheaper compared to STP. The coaxial cable uses, again, this type of shielding outside, and it can be distinguished easily from the UTP and STP using one core cable as opposed to multiple or 8 types of smaller core cables in the case of UTP and STP. So we'll talk briefly about the characteristics of each one. As we see here, we have the unshielded twisted pair. So you have 8 lines. Each line is colored differently using plastic material, and it's twisted like this. And then you have the outer jacket, which is used to package all these 8 wires and protect these packets from outside. And these plastic insulation or plastic insulators are colored to identify the cable and distinguish that cable from the other cables. The shielded twisted pair is distinguished, as we said, through the braided foil shield, which is used to eliminate the external interference, whether using electromagnetic or radio frequency signals. And then the other parts look exactly the same, like UTP. Due to this extra mitigation for electromagnetic interference, STP tends to have higher speed of communication compared to UTP. So UTP provides traffic in the range of 100 megabits per second or 1000 megabits per second, whereas the shielded twisted pair can actually support up to 10 gigabits per second, and therefore it's used for high speed Ethernet networks. The coaxial cable is slightly has different structures. So we have one single copper conductor wire as opposed to 8 different wires, and we have the plastic insulator around it, and you have a braided copper shield again to prevent the external interference from affecting the signal inside this copper conductor. Due to the thickness of this copper conductor, the signal here it tends to have more bandwidth and more energy, in which case the coaxial cable is used for example, the TV networks, as we are all familiar with the coaxial cable to connect our TVs to external antenna and so on. And of course, the UTP cable has replaced the coaxial cable for the Ethernet installations. The coaxial cable has actually been adopted for use in TV networks, in cable internet networks, and so on. So because of the fact that all types of copper cables they support the transmission of electrical signal inside the wire, they are prone to fire hazards. So they can be subjected to, they can be flammable, in which case they can fire easily. And of course, due to this electrical signals, the voltage of the electrical signal can get potentially high, in which case they can harm the network devices, whether it's a switch or a router and so on. And that's some of the disadvantages of the copper cables in general. So as we said, UTP does not have this braided foil shield, in which case someone might think that it's very much prone to electromagnetic interference. However, researchers they use two simple techniques for mitigating electromagnetic interference. Of course, not with the same quality like STP. However, UTP uses the technique of cancellation. So what they have found is that when you twist the wires like this, the electromagnetic field in one wire tends to cancel the electromagnetic field on the other wire, making the effect of crosstalk between these two wires is significantly reduced. Also, this can be more efficient when you change the twisting between the wires. As we can see here, the blue wire tends to have more twisting compared to the green wire. And using this, you can, in fact, reduce the crosstalk interference even more. So UTP cables tend to have different types. So we have all of them, they look the same. We have UTP Cat 3 or Category 3, and that tends to be suitable for voice communication, basically low bandwidth communication. So Cat 3 is used for phone lines, whereas Cat 5 or Category 5 is used for data transmission of up to 100 megabits per second or 1000 megabits per second. And Cat 5e supports the 1000 megabits per second transmission, whereas for Cat 6 it's used for very high data transmission up to 10 gigabits per second. So UTP cables, they use different connectors like RJ45, and these are the connectors for UTP, and we can say here that this will be detailed in the lab, so you'll be able to connect the wires to, or map the wires to some of these connectors, and use also the tester to make sure that that they work properly. What we need to talk about briefly here is the fact that we have three types of UTP cables. We have what we call straight through cable, in which case you have two basic configurations. You have 2568 and 2568B, and here the grouping of the wires is slightly different between A and B. So for straight through, the two ends of the wire need to have the same configuration. So whether it's T568A or T568B, both ends of the wire needs to be the same. Whereas for crossover, you can use one configuration on one end and another configuration on the other end. The difference between straight through and crossover is that for straight through, this is usually used for connecting different network devices. Like for example, you connect a host to a switch or to a hub. You use the straight through cable to connect a host to a switch or a hub. Whereas for crossover, it's usually used to connect two devices of the same type. Like for example, you can connect two hubs using crossover cable or two switches using crossover cable. Rollover cable is a proprietary type of cable, and we talked about what proprietary means, and this is actually used only for configuring the network device, whether it's a switch or a router. Again, you will go through all these types and details in the lab, and will be able to use a tester as well to test the functionality of these cables and make sure that they work fine. Also, you will be able to get trained on the color codes of these wires and map them to the different locations in the RJ45 connector. So now we talk briefly about the fiber optic cabling. So fiber optics is significantly different in terms of design compared to the copper cables. Fiber optics, they support optical light signal as opposed to electrical signal for the case of copper cable. And as we all know that light travels very fast, and that allows the fiber optic cables to support very, very high speeds of communications that can theoretically get in the range of terabits per second. And not only that, the light tends to travel very long distance, and as well the fiber optics, they tend to have very, very long distances, in which case they can be used for long haul networks where the distance between the two devices are very long in the range of kilometers. And even for the case of submarine networks where the fiber cable can actually be set up underneath the ocean for very long distances to facilitate long distance communication. So the structure of the fiber optic cable consists of here the core, and the core here is actually where the light transmission happens, and it's made of simply glass material to facilitate the transmission of the light signal through the glass. We have a cladding, which is also another type of glass material, which is used as a mirror to actually reflect any emitted energy from the core material to prevent it from going outside. So any emission from the light signal in the core here can be reflected by the cladding to make sure that the energy of the light signal is concentrated in the core part of the fiber optic cable. The rest of these parts are actually what we call outer jacket, and the outer jacket can potentially include a buffer, and this buffer material is used to protect the glasses inside here from scratches and things like that. And then there could be like some strengthening material which is used to strengthen the cable, as we might imagine that the core and cladding are made of glasses, and glasses can potentially be broken easily, in which case you need some strengthening material to make the core and cladding strong. And there is the outer jacket, which kind of packages everything in one unit. So fiber optic cables, they have two types. There is the single mode fiber optic cable, and there is the multi-mode fiber optic cable. Single mode fiber optic cable tends to have very, very thin core due to the fact that using very sophisticated light sources like lasers, you can have a very narrow beam of light which travels through the thin core of the fiber optic, in which case the dispersion of the signal is reduced or actually eliminated. So the light beam tends to have a very thin thickness, like here, like as we can see here, and it travels in one line. Due to this fact, the power or the energy of the light beam is concentrated in a certain direction, in which case the light beam can travel to very long distances, and it can have speeds which are very high. So the distances of the single mode fiber tends to have several thousands of meters, whereas in the multimode case, as we can see, the light beams can actually reflect through the cladding, and we call it multimode because you have a dispersion of different copies of the same light signal inside the cladding, which actually kind of disperses the energy of the light signal, in which case the distances of the multimode tends to be in the hundreds of meters, not in the thousands, because of the fact that the energy of the light signal actually decays through the distance, and because of that, the core tends to have more thickness, as we can see here in the tens of microns compared to the core for the single mode fiber optics. So these are the connectors, the different connectors for the fiber optic cable, and depending on the type of connector, we can actually use single mode fiber or multi-mode fiber and so on. And these different connectors we will go through in the lab in details, and we will be able to also test alignment of the fiber optic cable and whether the light can travel through the cable in an efficient way. So the fiber optic cables tends to have as well different characteristics, and to compare that with the UTP, we can see that for fiber optics, the bandwidth tends to be very high, of course, and the distance tends to be in the 100-kilometer range, whereas the UTP can have up to 100 meters only. Of course, immunity to electromagnetic external interference is very low in the case of UTP, and we talked about that, in which case the fiber optic is very much immune and is very much protected from electromagnetic interference. That gives all the advantages to the fiber optic cable. However, as we can see, the connectors tends to have very high cost for the fiber optic cables, and of course the installation skills, you need very skillful people to be able to set up the fiber optic cable, due to the fact that the dealing with light signal is very sophisticated, and you can have a misalignment of the light signal, in which case you can easily lose the communication, in which case you need very skillful people to set up the fiber optic cables. But however, in terms of electrical hazards, you don't have any electrical hazards for fiber optic cables because it does not deal with electrical signals, in which case you cannot have any high voltage that affects the network devices. And of course, in terms of safety, it's very high compared to UTP cable. Or the third type of media is actually wireless, and wireless tends to have very high sophistication in terms of facilitating the transmission because of many issues. Of course, you have the coverage range of the wireless signal, you have coverage area. So because of the fact that the electromagnetic signal of wireless travels through the air, it can have different impairments or that affect the coverage range of this wireless signal. Of course, the interference is very high for the case of wireless because the signal travels through the air and it's prone to different types of interferences. And as well, you have the issue of security because of the fact that the signal can travel through the air. Someone can easily tap into this wireless signal and try to get some information out of it, as opposed to UTP, which goes into a wire which is protected and the signal is protected inside the wire. However, wireless is actually the trend when it comes to data communications, due to the fact that wireless supports mobility and be very pervasive, and therefore there are hundreds and many actually standards related to wireless. So we have the very common standards related to Wi-Fi or 802.11, And all these different variations of Wi-Fi are actually standardized by IEEE. So Wi-Fi uses the technology of Cisna CA, which we will talk about later, and there are different variations of 802.11 standards. 802.11a, which works in the 5 gigahertz range, and 802.11g, which works in the 2.4 gigahertz, and G and N and AC and so on. These variations of the Wi-Fi technologies, they have different characteristics from what we call Bluetooth technologies, or 802.15, which supports short distance communication up to 3 megabits per second. And of course, we have WiMAX for long or broadband communication, which is used to support or to provide internet services, and this is standardized in IEEE 802.16 standards. And of course, this provides data rates of up to 1 gigabits per second over wireless. These wireless technologies, they use what we call wireless access point. So this is the picture of the Cisco Linksys wireless router, which uses an antenna which is built in, and it supports 802.11 AC, which means that it has data rates of in the range of hundreds of megabits per second. And of course, this has to be associated with a NIC card or network interface card, which has an antenna on the laptop or the wireless device that tries to connect to this wireless router. So using the wireless NIC cards and the wireless router, we can have wireless communication. So these are the different variations of the Wi-Fi technologies. This is a simple comparison between the different variations. So you have 802.11a, which tends to have a frequency range of 5 gigahertz and bandwidth of 54 megabits per second. This is a special type of communication compared to all the other technologies. As we can see, all the other variations of Wi-Fi, they support the range of 2.4 gigahertz, which is what we call unlicensed band, and all of them they support except 802.11a and 802.11ac. These support 5 gigahertz frequency, and there are some technologies which support both 2.4 and 5 gigahertz. The 5 gigahertz range tend to have less interference and tends to be more immune to interference from external devices. And as we can see, as we go down this way, the bandwidth or the data rate supported increase significantly from one technology to another, ending with 802.11d, which supports up to 7 gigabits per second.